Hello everyone, welcome to the next tutorial. In this tutorial, we are going to solve some more gate problems based on network theory basics. Okay, so the first problem that we have over here is we need to find the power delivered by the 2 ampere current source. Okay, so as you can see in the figure, let's say this is your reference node and the voltage across it is equal to 0 volts. So according to the given diagram, we can see that the node voltage over here is your 1 volt. Let's say the voltage at this node is your V1 and the voltage at this node is your V2. Okay. So on applying nodal analysis on this node, we can see that. So on applying nodal analysis, so let's say this is your current I1, this is I2. So on applying nodal analysis at this node, we can see that I1 is equal to -2 plus I2. It means that on 1 minus V1 upon 1 is equal to -2 plus V1 minus V2 upon 1. Okay. So on further simplifying it, we are getting 2 times of V1 minus V2 is equal to 3. Let's say this is your first equation. From the figure also, we can see that 1 minus V2 is equal to 1 volt. It means that V2 is equal to 0 volts. Okay. So this implies on substituting the value of V2 in this equation 1, we can see that 2V1 is equal to 3 and V1 is equal to 1.5 volts. Okay. So the power delivered by this 2 ampere current source, the power delivered by 2 ampere current source will be given as V into I. So the voltage across the current source is 1.5 and the current flowing is 2 amperes. So which is coming out to be 3 watts. Okay. So I hope it is clear. Okay. So now let's solve the second problem. Okay. So in the second problem, it is given that the parameter K is positive and the power dissipated in 2 ohm resistor is 12.5 watts. So we need to find the value of K in this network diagram. Okay. So in this network, okay. So as you can see, the power across 2 ohm resistor is given to be equal to 12.5 watts. So it means that we know that P is equal to I square R, or you can say V0 square upon R, because the voltage across the 2 ohm resistor is your V0. So it means that V0 square upon 2 is equal to 12.5 and we are getting the value of V0 to be equal to 5 volts. Okay. So we can also find the current which is flowing from this 2 ohm resistor. So it means that the current flowing from 2 ohm resistor I is equal to 5 upon 2, which is equal to 2.5 amperes. Okay. So on applying KCL at this node, we can say that let's say this is your node 1. So at node 1, on applying KCL, we can say that 2.5 is equal to minus K times V0, because the current flowing in this 10 ohm branch is your KV0 plus 5. Okay. So it means that from this equation, KV0 is equal to 2.5. Also, we have already found the value of V0 to be equal to 5 volts. It means that like the value of k will be equal to 2.5 upon 5, which is equal to 0.5. So k is basically constant, so it will not have any kind of unit. Okay, so the value of k is equal to 0.5. So I hope it is clear how we are solving this problem. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.